Hello, this is Mr. Henry, and welcome to lesson 4.9. In this lesson, we'll be talking about the equation of a line. The center question says, how do I write the equation of a line in all three forms? We've seen one form called standard form. We're going to see all of the forms, and we're doing quite a bit more algebraic work, working with our equations and solving and moving stuff around left and right. The warm-up asks, give a brief summary about how to find the slope of a line from 2 points and from a graph. So if you did this already, your summary probably says from 2 points you use the formula m equals y2 minus y1 over x2 minus x1. And you plug in your points, you simplify, you evaluate, and you get your slope. From a graph, you try to find two well-defined points, and then you count the boxes. So in this case, it might have go like up 2 over 4, so the slope would be up 2 over 4, which simplifies to 1/2. That sort of thing. Okay, so our vocabulary, these are the three forms of a line, the three different ways to write the equation of a line. So the first one is called point-slope form, and it is the ugliest of the three. Point-slope form says y minus y1 equals m times x minus x1, where m is the slope. Just like in our previous examples, we've been writing m equals whenever we do slope, because the m variable is used for slope. And x1 and y1 is a point on the line. Okay, so that's the form we're going to start with the most. And then after we have point-slope form, we're going to change it into slope-intercept form. So slope-intercept form is the equation y equals mx plus b. This is probably the most popular form of writing a line, slope-intercept form, where m is still the slope and b is the y-intercept. So if you remember, the y-intercept happens where the line crosses the y-axis. That's the y-intercept. It happens where the x value is 0. And finally, standard form, which we've seen before, but you may not remember it, is the form ax plus by equals c, where a and b do not equal 0. So those are the three forms of an equation. So let's get to it. We're going to write these down. Now, I would like to mention that the method that I'm going to show you here is not the quickest method all the time. But a lot of people would rather learn one method that works everywhere, even if it's just a little bit more complicated, instead of learning like 3 or 4 different methods. So the method I'm going to show you works pretty much all the time. It's going to be step by step by step, changing from one form into the next, and we're going to get all 3 forms by doing one process. Okay? So here it says, write the equation of a line in all 3 forms, and we're given a point and a slope. Okay, so if we're given a point and a slope, the method that we're going to do is we're going to start with point-slope form. So we're going to write that down. Y minus y1 equals m times x minus x1. That's the formula from point-slope form from our vocabulary. Now we simply plug the numbers in. So the m value is 3. This x stays x. This y stays y. It's the x1 and the y1 that come from this. So this is obviously the x point is the x1, the y point is the y1. So I'm going to have x minus -2 and y minus -8. So it's a minus in the equation, and there's a negative in the problem, in the point. With just a little bit of simplifying, we already have our first formula done. I'm just going to simplify this minus and negative into a plus. And minus and negative becomes a plus. This is my first form, which is point slope form. So point slope form is done. It takes a point and a slope. You plug them in. You might have to simplify. You might not. And you're done. Now, we're going to take this point slope form and we're going to change this into slope intercept form. Slope intercept form, if you want to look back at the vocabulary, has y equals. So that's what we want to do. We want to get the y variable by itself. So let's look at our formula. Here it is. Okay, so if I get this y variable by itself, I kick this 8 over to the other side, we'll pretty much be done. Now there's one thing I want to do before I do that, and that's just to simplify this right-hand side a little bit. So I'm going to simplify. I'm going to distribute here. Give me a 3x, remember, 3 times x, 3 times 2. Now when I kick this 8 out, minus 8 on both sides, I have y equals 3x minus 2. This is the same equation, but in slope intercept form. So the slope is still 3. The intercept is negative 2. The last step we're going to do, it's only going to take one step, is to get to standard form, we get the x's and the y's on the same side. So if I take and I get this x over there with the y, I'd be done. So let's do that. So we're going to subtract 3x minus 3x gives me negative 3x. I'm going to move them over a little bit. Negative 3x plus y equals negative 2. This is the same equation in standard form. Now, I can show you graphically that these are the same thing. I have a program called GeoGebra. It helps me just do some graphics. So I'm going to graph all 3 of these lines. So the first one I'm going to take is, if you look at the bottom of the screen, you'll see y plus 8 equals 3 times x plus 2. Enter. So we have this line it's showing us here. Okay, second equation, y equals 3x minus 2. You may not notice it, but the same line is over top. It's the same line. And if I graph the third one, negative 3x plus y equals negative 2. Again, we have the same exact line. All 3 lines are right over top of each other. So this is the same thing. It's just written 3 different ways. And this method may seem quite complicated at first, but with practice, it's quite easy because you're going to be doing the same thing every single time. So it becomes familiar to you and you don't have to think about it. It kind of becomes automatic. Okay, I'm going to erase this stuff in the middle because I'll need the space to do the letter B here. Letter B. Same thing. So I'm going to start with point slope form, change it to slope intercept form, and finally standard form. So point slope form starts with y minus y1 equals m times x minus x1. x1, y1. So my formula becomes y minus 1, there's the y1, equals negative 4 x minus 1. This is point slope form. To change to standard form, I want to get the y variable by itself. I'm sorry, not standard, slope intercept form. I want to get the y variable by itself. So I'm going to do a little bit of simplifying over here. Distribute negative 4x plus 4. Add 1 to both sides. Gives me y equals negative 4x plus 5. This is slope intercept form. Slope intercept form is in the form y equals mx plus b, where this is your slope, this is the y-intercept. Finally, I'm going to change this into standard form. Standard form is in the form ax plus by equals c. And for that to happen, I need to get the x variable on the same side as the y variable. So I'm going to add 4x to both sides, giving me 4x plus y equals 5. And this is standard form. Now, in a typical problem, you probably will not be asked to write it in all three forms. I mean, if you're quiz, test, PSA, whatever, it might say, write the equation of the line with this point and this slope in slope-intercept form. So you could go as far down as you need to. If it says slope-intercept form, boom, you could stop right there. You're done. If it says write it into point-slope form, you can stop at the very beginning and you're done. If it says go to standard form, well, then you do have to go the whole way down to here. This I've found over experience to be a nice, easy method once you get the hang of it. So you set up in point slope form. You solve for y, slope intercept form. You move the x and the y together, standard form. So there's all three forms in a matter of, I'm counting, let's see, we got 1, 2, 3, 4, 5 steps. You have 3 forms. Okay? Here's one I'd like you to try for yourself. Go ahead and write the equation of that line in all 3 forms right now. Okay, so if you didn't do it yet, obviously pause the video and do it for yourself. Try it for yourself at least. And I'll do it now. Y minus y1 equals mx minus x1. This is what point slope form looks like. That's my x1 and my y1. So I have y minus 1 equals 4 times x minus negative 3. I'm going to pretty this inside up a little bit, become 4x plus 3. And this is point slope form, because it takes a point and a slope. Now I'm going to change this into slope intercept form. First, I'm going to pretty this right side up by distributing 4x plus 12. Add 1 to both sides to get the y variable by itself. Y equals 4x plus 13, which this is now in slope intercept form, which is y equals mx plus b. This one is the y minus y1 equals mx minus x1. And then finally, to change this into standard form takes one step. Get the x and the y together. So if I subtract 4x on both sides, there we go. We get negative 4x plus y equals 13. and that is standard form, which looks like ax plus by equals c. Now, I mentioned earlier that this method pretty much always works, and it's true. No matter what information you're given, you could pretty much do this same method. If it gives you a point and a slope, boom. In the next examples you're going to see, it's going to give us 2 points. We're still going to use the same method. We just have one extra little step first. If they gave you a point and a slope and an intercept, well, that intercept is still a point. That's the intercept, like the y-intercept, happens when the x value is 0. So if they told you the y-intercept is 5, well, you know it's a point 0, 5. So you still have a point, you'd still have a slope, you could still plug it in and do the exact same method. Now, what's missing here from using that formula, or the form y minus y1 equals m x minus x1? We have a point. In fact, we have 2 of them. What's missing is the slope. You always have to find the slope in order to write the equation of a line. That's needed. You have to have it. So we're going to take the 2 points they give us. We're going to find the slope. Then we can write the equation of the line. So the space I skipped here was space for you to find the slope. So back to the slope, slope formula. x1, y1, x2, y2. So that gives me m equals y2 minus y1 over x2 minus x1. You write down the formula. 1 minus 4 over 2 minus 6 gives me negative 3 over negative 4, which is just 3/4. Remember, leave the slope as a fraction. It's fine as a fraction. Now we have the slope, and we have points. We have 2 of them. We can plug this in. So 3/4 is my slope. And the next question I get asked typically is, how do I know which point to use? The answer is, doesn't make one bit of difference. You can use either point and it's going to give you the exact same answer. So you pick a point that works for you. If you like picking this second point because the numbers are smaller, hey, go for it. If you want to pick this second point because maybe you like the number 4 and 6 better, go for it. So it doesn't really matter what you use. I'm going to use the second point because the numbers are smaller, and I like small numbers. So 2 goes here, 1 goes here. This is in point-slope form. So that's the y minus y1 equals m x minus x1. I'm going to change this now into slope-intercept form. So I'm going to pretty this up and distribute and get the y variable by itself. So to pretty this up, that's going to give me a 3/4 x. That's 3/4 times x. 3/4 times by negative 2 is going to give me a negative 6/4, which simplifies down to negative 3/2. Not the prettiest thing in the world, but it's not bad. If you don't like this, you could, because this is not the slope. This guy here is the slope. Slope, stay fraction. If you don't like this as a decimal or as a fraction, you can change it to a decimal. 3/2 is just 1. Oopsie, 1.5 is what I meant to put. 1.5 is fine. And then we get the y variable by itself, so I add 1, y equals 3/4 x minus 0.5, which this is now in slope-intercept form, y equals mx plus b. So this is the slope, this is the intercept. Actually, from this form, I can tell you right now exactly what this graph looks like. So this graph crosses the y-axis, the intercept, at negative 0.5. So right there. It has a slope of 3/4. So I'd go up 3 over 4. Up 3 over 4. That is what this line would look like. But we're just trying to change it into all three forms. So if I go through and change this thing into standard form, I'm going to subtract this 3/4 x to both sides because it's positive, so you have to subtract it away. He cancels out, just like he canceled out, and we get negative 3/4 x plus y equals negative 0.5. And this is standard form. Standard form, which looks like ax plus by equals c. And there we go. So we had the one extra step at the beginning of the problem by finding the slope first. I'm going to erase most of this, all the stuff in between, because I need to do the second problem. So erase there, and there, and there, and all that stuff. All right. Letter B. Same deal. So you always have to find the slope in order to write the equation of a line. Even in standard form. Standard form, if you look down here, it doesn't actually have slope in it. But it sort of does. That is kind of the slope, this negative 3/4, but it's not actually the slope. But you still need the slope in order to write the equation in standard form. So the first thing you're always going to do, if you are not given slope, you are always going to find the slope first. First thing first, find slope. So m equals y2 minus y1, x2 minus x1. Always find the slope first. x1, y1, x2, y2. It's probably too big. Alright, let's see. y2 is 7 minus negative 2. Boom, boom. 5 minus 2 gives me 9 over 3, which is 3. That's a nice easy slope. I like it. Okay, Pointslope form. Y minus y1 equals m, x minus x1. Y minus, I'm going to use this point because both numbers are positive. That is literally the only reason. I don't like having these negatives, especially when I'm going into Pointslope form, because then you have minuses and negatives, and you have to pretty it up a little bit. So if you use just positive numbers, it saves a step. So y, this point I'm using here. So the y value is 7. M is 3. X minus the x value is 5. So this is done in Pointslope form. Now we change it to slope intercept, so we're going to distribute and get the y variable by itself. So pretty the side up, 3x minus 15. Add 7 to both sides. Y equals 3x minus 8. This is in slope intercept form. And to get to standard form, we get the x and the y together. So I'm going to subtract 3x, giving me negative 3x plus y equals negative 8. And that is standard form. Okay. So just remember that the you don't always have to go from here down to the bottom. It depends on what the question asks. If it asks for point slope, you can stop right there. And if it asks for slope intercept, stop there. And if it asks for standard form is the most work, you go the whole way to the bottom. Here's one for you to try. Go ahead, pause the video right now. Do this on your own. When you're ready to continue, hit play. We'll go through it together. All right, so first things first, you have to have slope. So we're going to find slope. M equals y2 minus y1 over x2 minus x1, giving you x1, y1, x2, y2, 4 minus 0 over negative 2 minus 0, giving you 4 over negative 2, which is just negative 2. So the slope of this line is negative 2. Into point slope form, y minus y1 equals mx minus x1. I'm going to use this guy because not only are they both positive, but they're both 0, and I think that's going to make my life quite easy. So y minus 0 equals negative 2, x minus 0. This is point slope form. If I'd simplify and pretty this up, we end up with just y equals negative 2x, which this is slope intercept form. You might be asking, but Mr. Henry, where is the intercept? I mean, I see the slope. The slope is this negative 2, but what's the intercept? The intercept, it's still there. It's hiding. It's right here. You see it? There it is. The intercept is 0. This line goes through the y-axis at the origin. See? That's a point on the line, 0, 0. So the y-intercept is at 0, and this guy has a slope of negative 2, so it's going to be going downhill like that. And then we're going to change this into standard form. So to get standard form, you get the x's and the y's together. So we're going to add 2x to both sides because the 2x is negative, giving us 2x plus y equals 0. And that is standard form. Okay, so let's see our next page. It says, what pieces of information do you need to write the equation of a line in any form? What pieces did we always need in every single problem we've done so far? Well, you always have to have slope. That has to be there. And you need at least 1 point. You can have more points. They can give you 2, 3, 4 points, whatever. But you have to have at least 1 point, and you have to have a slope. Now, that 1 point might be a y-intercept, where they say the y-intercept is 5. I used 5 as an example already. The y-intercept is negative 2. Well, that is the point 0, negative 2. The y-intercept happens when the x value is 0. So that y-intercept is the point 0, negative 2. So they're still giving you a point. It's just kind of hidden in a different method, in a different way of showing it. So those are the things you need. A point, a slope. If you don't have a slope, you find the slope. If you don't have a point, you find a point by looking at a graph. Speaking of looking at a graph, the next couple problems ask us to write the equation of the line in all 3 forms given a graph. Okay, so what we have to do is essentially the same thing. We still need the same 2 pieces of information. We need the slope, and we need a point. Now, first thing, to find slope, you need those well-defined points, those places where the line is going right through a crisscross. There's one, and there's one. So I can find the slope graphically by counting the boxes. It's quicker and easier than doing the slope formula. But if you don't trust yourself counting boxes, you can use the formula. But the slope here is from this point to the very next point, you go up 2 over 1, 2, 3, 4, 5. Up 2 over 5. There is my slope. And to find a point, well, you pick any darn point you want. I'm going to pick the one that has a 0 in it. That one looks pretty easy. That's the point 0, 1. So that's everything I need in order to write the equation of this line in all three forms. So let's do that. We have y minus y1 equals m x minus x1. That's our point slope form because it takes a point and a slope. And we plug our point and slope in. So y minus 1 equals 2/5 x minus 0. That is point slope form. Then to get the slope intercept form, we're going to get the y variable by itself, but first we need to pretty this side up, so we're going to distribute 2/5 x, and 2/5 times 0 is 0, so I just put my plus 0 there. Add 1, y equals 2/5 x plus 1. There is my slope intercept form. And then to get to standard form, we get the x and the y together. So I'm going to subtract 2/5 x, giving me negative 2/5 x plus y equals 1. And that is standard form. So find a point, find a slope, plug them in, there you go. So it's the same method essentially. You just have to find the points yourself or find the information yourself. Instead of it just telling you what the slope and what the intercept is, you have to go through and find the slope and intercept yourself. Letter B. Some well-defined points are there, and there it looks like, and there it looks like. So from one to the other, my slope, I'm going to go down 1, 2, 3, 4. Down 4 over 1. So my slope is negative 4. My point, well, I don't have any points that have just positive numbers. So I'm going to pick this one because it has a 0 in it and it's small. That's the point. Negative 1, 0. It's the one that's closest to the origin. So I'm going to pick that point. Negative 1, 0. And we do the same math. Y minus y1 equals m, x minus x1. Y minus 0 equals negative 4, x minus negative 1, which this minus a negative 1 is going to turn into a plus 1. So there is my point slope form. And then we change it to slope intercept form, so we get the y variable by itself, which sort of already is because this minus 0 doesn't do anything. So we have y equals, but we need to pretty this up. So we're going to distribute, giving us negative 4x minus 4, which this is now slope intercept form. And finally, to get to standard form, we're going to add 4x to both sides, giving us 4x, that didn't look like a 4 to me, 4x plus y equals negative 4. That is standard. So that was pretty easy. That was pretty quick. It helps by choosing good points, points that are close to the origin. They give you, sometimes if you use the intercepts, it'll give you zeros, and it helps out a lot. Okay, here's one for you to try. This is example C, or example 3C. It says, write the equation of a line in all three forms given the graph. So go ahead, pause the video right now, do this problem on your own. You're ready to continue, hit play, and we'll go through it together. Okay, so let's see here. Well-defined points. I've got that looks like one, and there, and there, and there. So I've got a bunch of them to choose from. So I can just pick any of them. So I'm going to go up 1 over 2. So my slope is up 1 over 2, 1/2. My point, I pick any of them. None of them are really close to the origin, so I'm going to pick the one that has a 0 in it, this guy here. That's the point 0, 1, 2, 3, 4. So that's all the information I need. Now I go through and I do the work. So y minus y1 equals m, x minus x1. Y minus the y value equals the slope times x minus the x value. And this is going to cancel out. It's going to be gone because it's just x minus 0. But for now, this is point slope form. This side becomes just 1/2 x, y minus 4. So simplifying a little bit, add 4 to both sides gives me y equals 1/2 x plus 4. This is slope intercept form. And finally, to change the standard, we're going to get this x term over on the left side. So I'm going to subtract 1/2 x, giving me negative 1/2 x plus y equals 4. This is standard form. So all in all, the problem doesn't take terribly long to do. It's a lot of little steps and it's solving equations, but that's what algebra is all about. But not complicated, just little steps. Next example, little application. It says here, in class, the students were asked to write the equation of a line going through the points 4, 3 and -1, -7 in 3 forms. 2 students did it 2 different ways. Find out which, if any, students did the problem correctly. Then fix the mistakes of the student or students who did the problem wrong. So we're given Megan's method, and this is what Megan did. And we're given Jack's method. And that's what Jack did. Now, typically to do this, I don't know, we could go through and check out their steps. So let's see here. So x1, y1, x2, y2. So if you're finding the slope, you would have -7 minus 3 over -1 minus 4. Uh-oh. That's not what Megan has. She put the x numbers on top. Her fraction is upside down, so her whole slope is upside down. Instead of being -1/2, it should be -2. That's going to cause some problems for Megan in the future. Okay, so let's see what else she might have done wrong. So this, if we imagine, this should be a -2. Make my line thicker. There we go. So got a -2. Let's see, did she plug the right y variable in there? The y value? It should be y, what happened? There you go. It should be y minus the y value. So y minus -7. See? Megan messed up again. There should be a minus a -7 should turn into a +7. And the same thing over here, it'd be minus a -1 would turn into a +1. So this would be a plus. and this would still be a 2. And now, when we distribute negative 2 times x is negative 2x, negative 2 times by 1 would be a negative 2. So that would be a negative 2. And then, what did she do? She subtracted 7 on both sides, I think. Or added 7. You'd have to subtract it. You'd minus 7 on both sides, which would give you a negative 9. And so negative 9, and that would be a positive 2. So Megan made lots of little mistakes. She had her slope upside down, and when she plugged her numbers into point slope form, she forgot that it's minus a negative. She just did, instead of it being y minus y1, and the y value she used is negative 7. Come on, there it is. Y value of negative 7. It should be y minus negative 7. She just did y minus 7. And then the same thing happened on the x side. Everything else looked okay. I mean, her steps after that, her math she did wasn't wrong. It's just the problems at the beginning of the problem made lots of mistakes later on. I mean, that slope, that one problem right there, it carried down the whole way through every single step. So every single step was wrong because she messed up at the beginning. She messed up here with the plug into point, so every other step after that was wrong as well. Okay, so Megan wasn't right. We found her mistakes. What about Jack? So it's the same exact problem. So again, to find the slope, if this is x1, y1, x2, y2, we'd have negative 7 minus 3 over negative 1 minus 4. Okay, that's not what Jack has either. But is he wrong? I don't think so. Let me check. Let me finish mine here. So this negative 7 minus 3 gives me a negative 10. Negative 5 equals 2. No, Jack's not wrong. We got the same slope. All Jack did is, instead of using this is the x1, y1, and this is x2, y2, he had them backwards. He said x2, y2, x1, y1, which is not wrong. You can do that just fine. You can name them anything you want. So the slope's correct. So he's correct so far. Okay, so let's see. Slope got plugged in. Okay. He's using the point, the first one, the 3 and the 4. So let's see. The x value is 4. The y value is 3. Did he plug them in right? The x value is 4. Y value is 3. Okay, he's good so far. He distributed 2x minus 8. Looks good. What did he do? So it looks like, I mean, he moved this piece over there. So he would subtract 2x. That's not how we did it before. But is it wrong? I don't know. Subtracted 2x and then added 3. Okay, so he got to standard form first, which is not wrong. I mean, this is the standard form of that equation. It's just not how we've done it. And then he added 2x to both sides and got slope-intercept form. Okay, so Jack is basically doing the same problem, just not the way we normally do it. If we would do the problem our way, the way we've been doing it in the past, we'd have the y minus 3 equals 2 times x minus 4. We would distribute y minus 3 equals 2x minus 8. We would add 3, y equals 2x minus 5, which is what Jack has right here. That's the slope-intercept form. And then we would subtract 2x to both sides and get negative 2x plus y equals negative 5, which is what he has here. So he just did it in a different order than we're used to doing it, but it's not wrong. So, summary. How do you write the equation of a line in all 3 forms. Just give a little step by step. You don't have to write a big long paragraph. Give me the process to do this. Okay, so I have here, first you must have the slope of the line and a point. If you don't have either of those things, find them. Then you write the equation into point-slope form. Solve the equation into slope-intercept form. Finally, rewrite the equation into standard form. And that's how you do it. This has been lesson 4.9. Thank you for watching.